just like yesterday, the whole idea of the opener is to review for the test that we're going to take tomorrow. So there's a few different types of problems here. First problem, when we have a square root like the square root of 100, we can simplify that a couple of different ways, and I'm going to go ahead and do both ways. The first way is a way we would simplify any square root, and that's by starting by factoring. So we could do 10 times 10, and then each of those 10s would be 5 times 2. And so when we do it this way, the next thing we're going to do is rewrite it. So instead of the 100 in the square root, we're going to have 2 times 2 times 5 times 5. And then what? Circle pairs. So we got a pair of 2s and a pair of 5s. And since everything is circled, that means everything is going to be on the outside, and the square root's going to be gone. So on the outside we have 2 times 5, which is 10, and that's your answer. Do not put a square root on that. If everything's circled, everything's on the outside, there's no square root left, so do not put a square root on it. Alright? Now, also keep in mind that when you're doing this on the test, a problem like this is going to be worth 3 points. You only get 1 point for getting the right answer. The other 2 points are for showing work, okay, showing how you got that answer. So be sure that not only you know how to get the answer, but you can also show how you got the answer. All right? Anybody do this one a different way? There's a quicker way to do this. Since 100 is a perfect square, instead of factoring and writing out all the prime factors, we can just write 100 as 10 squared. So we're rewriting it, and instead of 100 we put 10 squared inside that square root. And now with the square and the square root, what's going to happen? They're going to cancel each other out. So the square and the square root cancel each other out, and what does that leave? 10 all by itself. Again, no square root left because the square root canceled with the square. Alright, so this way's a little bit quicker. This way works great when it's a perfect square. Would this work if the number was not a perfect square? No. If the number's not a perfect square, then we're going to have to do it the other way. Alright, how about this one? We're actually going to have to simplify these square roots before we can add or subtract them, right? So when we're adding and subtracting, remember, we can only combine them if they're like terms. So we can't put them all together in one square root like we've been doing with multiplication. We need to keep them separate unless they're like terms. So we're going to simplify each one of these, and none of them are perfect squares, so we're going to have to do them by factoring. So we'll factor each one of them. Notice that I'm only factoring the radicands. We don't need to worry about the coefficients at this point. Alright, and since we are keeping these factors separate, since we're not putting them all together in one square root, it's important that we know which factor trees are which. Don't start mixing them up, so we need to keep those separate. Next step, just like when we're simplifying a square root, is to rewrite it. Now we need to be careful of a few things when we rewrite it. The first is, on that first term, what do we need to make sure we have? That 3, yes. Don't forget the coefficient when there is one. So we've got the 3 coefficient, and then inside the square root, what are we going to have? Okay. Then we're going to have a plus before the next one, and inside that square root for the 80, we're going to have... Okay. And then we've got minus, don't forget the 2 out front, and then for the 20 we're going to have lots of 2's and 5's here. Alright, now what? Now we circle pairs, so it's just like what we did when we simplified the square root of 100 by factoring. So we've got a pair of 2's, pair of 2's, pair of 2's, and a pair of 2's. And each of those pairs is going to go on the outside. So what we end up with for the first one is a 3 on the outside, but a 2 joining it. So we're going to have 6 square root of 10 plus
4 square root of 5.
Okay, and then minus
4 square root of 5.
Okay, good.
Can we
find common denominators.
Not a common denominator, but common like terms, right? So we're looking for like terms now. Do we have any like terms here?
Yeah.
Yes. The other thing we want to make sure we do is we want to write them in the correct order. So let's start with the one that we want to go first. So what's going to go first? The square root of 10s or the square root of 5s? The square root of 5s first. Okay, so let's combine those. What is 4 square root of 5 minus 4 square root of 5?
Square root of 5.
What do you guys think? Is it square root of 5? So if we write down square root of 5, that would mean that it's 1 square root of 5, right? So 4 minus 4 is 1. Is that what we're saying? No. What is it? It's 0, right? So actually what's happening here, we have a 4 square root of 5, and then we're subtracting 4 square root of 5. It's like if we had 8 bananas, and then we subtract 8 bananas, what do we have left? We don't have anything left, right? At least we don't have any bananas left. So if we have something and then we subtract that something, it's gone. They cancel each other out. So these right here, the 4 square root of 5 and 4 square root of 5, they just cancel out. It's 0 square root of 5, but 0 square root of 5 is just 0, and we can leave that off. All right? So then what do we do? What's our answer?
6 square root of 10.
Yeah. We still need that 6 square root of 10, but we don't have anything left with the square root of 5. So our answer is just 6 square root of 10. All right, this next one is multiplication. With multiplication, we don't have to make sure they're like terms that combine them. We can combine them no matter what. All right, so to do that, we'll start by factoring. And this is just going to save us some work later. So 42 is 6 times 7. And then 6 is 2 times 3. And the 24 is 6 times 4. 2 times 3, 2 times 2. Alright, so once I've factored it, what's the first step we want to do? So if you look at your notes for multiplying square roots, the first step says multiply coefficients. So our coefficients are 5 and 3, so 5 times 3 is 15. And then once we multiply the coefficients, we're also going to multiply the radicands, which is step 2. But instead of multiplying 42 times 24, what are we going to do? We're going to put all of those factors in one square root, right? So by multiplying 42 times 24, we're just going to multiply all of these factors times all of these factors, and we're just going to put them in order. So how many 2's do we have? Okay. And then how many 3's?
2.
And then we have a 7, it looks like. Okay. Then what? Yeah, now we just need to circle pairs and simplify like we normally do. Alright, so we've got a pair of 2's, a pair of 2's, and a pair of 3's. So on the outside, we already have a 15, and then we're going to have a 2, another 2, and a 3 go out and join, and we're going to multiply them all together and get 180 on the outside. And what about the inside? Last one on the opener, we're dividing the square roots this time. So the fraction means division. All right, what is the first step in dividing a fraction? Can we simplify coefficients here?
No.
No. We do have a coefficient 6 here, but we can't simplify with the coefficient in the bottom because that would be 1, so that doesn't work. How about radicands? Can we simplify those? Yes. So the 15 on top and the 30 on the bottom can both reduce by what?
5.
Alright, so we can reduce by 5. 15 divided by 5 is 3. 30 divided by 5 is 6. Okay. And then do we need to move on to the next step then? No, not yet. What can we do with the 3 and the 6? We can reduce those too, can't we? So we need to make sure that when we simplify completely. All right, so we can reduce the 15 and 30 by 5, but that's not it. We're not done. What else goes into 3 that also goes into 6? 3. So we'll reduce by 3, and when we reduce by 3 on top, what's going to happen? It just cancels out completely, right? It's really a 1, but since we have something else up there, we don't need to put the 1 there. All right, so the top square root is gone. That canceled out completely. What about the bottom? What's 6 divided by 3? 2. All right, so then can we reduce any more? No. What about the 6 with the 2? Can we reduce those?
No.
No, why not?
6 on the outside and 2 is actually square root.
Yeah, 6 is on the outside, 2 is on the inside. Don't forget, since this 30 was inside the square root, these numbers we get when we reduce it, those are also inside the square root. So just to write down what we have at this point, we have 6 over the square root of 2. Once we've simplified, now we need to get rid of the square root in the denominator. So how are we going to do that?
Times 2. You mean times square root of 2.
Just times the square root of 2?
On both top and bottom.
Okay, so we're going to multiply by the square root of 2 over the square root of 2. Alright, it's important that we multiply by the square root of 2 in both parts, because if we just do one and not the other, then it's unbalanced, and we're changing the value of this expression. Alright, so on top, what is 6 times the square root of 2?
6 square root of 2.
Yeah. You can now multiply the 6 and the 2 together to get 12, because the 6 is outside, the 2 is inside. So we'll just keep the 6 outside, we'll keep the 2 inside, and get 6 square root of 2. How about the bottom? What's the square root of 2 times the square root of 2? 2. Now are we done?
No.
What else do we need to do?
Divide.
Yeah, we can reduce one more time, or simplify, or divide. 6 divided by 2 is 3, so we end up with 3 on the outside, and so we get 3 square root of 2. Again, when we reduce there, we get a 1 on the bottom, but we don't need the 1 on the bottom, because if you divide by 1, it doesn't change anything. Alright, so 3 divided by 1 is the same thing as 3.